Hi everyone, this is Darshan Senthil, and in this final video on limits, we shall be talking about the limits as x approaches infinity. This is what I hope will be a very short video, so it's just to talk about a couple of things to wrap up limits, okay? So, limits as x approaches infinity. When considering limits as x approaches infinity, we must take into account the functions and behavior. Okay? We must take into account the functions and behavior. So, on another interesting note, this also serves as a test for horizontal asymptotes for rational functions, and rational functions are functions that have fractions in them. So these are things that we'll be looking at in this video more in depth. So yeah, let's take a look. So for continuous functions that is functions that are continuous everywhere, this is what we have. So two things you need to look at when considering the limits as x approaches infinity. You must look at the leading coefficient and you must look at the degree. And the degree is basically the highest power on the function. Okay, so these are the two things you need to look at, and then you need to ask yourself the following questions: is the degree positive or negative? So is the leading coefficient positive or negative? And is the degree even or odd? Two questions you need to ask. And then, oh sorry, I erased that by accident, but here is what will happen then. If your degree is even and your coefficient is positive, you get something like this. And this is much like the graph of y equals x squared. It'll look something like this. Again, it won't look exactly like this, but in general, that's what the shape should look like. And if it's positive and odd, it means it's going to be like this. As you see here, much like the function y equals x cubed. And if you flip the sign of the leading coefficient, the graph basically flips downwards. Okay, it just flips the other way around. So that's the basic idea of it. These things are helpful to keep in mind when you work through examples, as it'll really help you just solidify those concepts in your head, and it'll also allow you to think intuitively and just think what could be happening to a function at any given point. Okay, let's move on. So for rational functions, you always start by looking at the degrees. And to be specifically, you have to look at the degrees of both the numerator and the denominator. Okay, you need to look at those two things. Here's a little flow chart that depicts what happens. You know what, let me go ahead and erase that. Okay, compare the degrees of the numerator and the denominator. If the denominator is greater than the numerator, so for example, let's make an example function. Let's take that for example. If the degrees of the numerator and the denominator, if the numerator is greater than the denominator, like it is here for example, like 2 is greater than 1, then this should be limit as x approaches infinity of f of x. This would be infinity, or it would be negative infinity if you were going to negative infinity, but that's another thing. So it would just be infinity. And if you think about this logically, as this goes really, really high, this doesn't increase at the same rate. So therefore, at some given point of time, this is going to outstrip this completely. So, for example, if we plugged in 2, this would be 4 plus 2, and this would be just 3 times 2. If we plugged in 4, this would be 16 plus 2, but this would only be 3 times 4. So eventually this is going to go really, really high, and this will just not be able to keep up. That's the idea behind it. If the numerator equaled the denominator, then this is just a little bit complicating. It's going to be the ratio of the leading coefficients. Okay, so for example, if you had 2x squared plus 3 over 1 plus x squared, you'd take the ratio of the coefficient. So this case would be 2 over 1 because this is basically 1x squared, so the answer would be 2. So that's the idea there. And again, the concept here is that since both these are increasing at sort of the same rate, they will they'll sort of hit this common ratio there. Okay. Now what happens if the numerator is less than the denominator? Like for example, in 6x over 3x squared minus 1, well, the answer would be 0. Okay, and again, think about this intuitively. If the denominator increases faster than the numerator, then at some stage you're going to get a fraction that's something like 16 over like 300 or something like that, and this will keep getting, and as you know, as this fraction gets smaller and smaller, it's going to get, as the denominator gets really big and this thing gets small, you're going to get really, really, really close to 0 as you keep going further on, which is why that's 0. And in addition, these are also, I should remind you, these are functions horizontal asymptotes. Just a little fun fact. These are functions horizontal asymptotes. Okay. So, and that's about it for this video. That's all I wanted to talk about. I may get some examples done in a future video, but these are all, it's mostly concepts that you need to know with this. The examples are very, very easy. It's all about the concept that you understand here. Okay. So, thank you for watching and have a nice day.